Class 12 Science, Subject Physics, Topic Torque on a Dipole in a Uniform Electric Field. Chapter 1. So today we will discuss about the torque on a dipole in a uniform electric field. Now for that we need to first draw the diagram. In this diagram, first you need to draw the parallel uniform electric field. And this is represented by these arrows. So we know that when an electric field is uniform, they are equally spaced, and this is how we place the dipole. Understood? This is one charge and this is another one. So this one is considered to be plus Q, which is experiencing a force QE, and this one is experiencing the force minus QE, and the direction of both the forces are opposite. See, this arrow is pointing, and we know that the distance between the two dipole is considered to be 2a, and we know that the dipole is inclined at an angle theta, and this is the angle of inclination, that is theta, with the field. And the 2a has a two component, one is horizontal component, another one is perpendicular to the field, that is 2a sine theta. Now to understand this further, we need to consider the few assumptions that are, let us consider. First one is plus Q and minus Q be the charges. 2a is the length of the dipole. E is a vector quantity, that is why arrow is there, and it is uniform electric field, and theta is the angle. Theta is the angle between electric field and dipole axis, and dipole axis. So we put the magnitude of the dipole moment, which is the product of magnitude of dipole moment, which is the magnitude of dipole moment is represented by P, and it is the magnitude of one of charge and the separation distance between them, that is what, 2a. Now we will consider what is the force exerted by each charge. So positive charge experiences plus QE, and negative charge experiences minus QE. Then total force. Which force? Translatory force, remember that. So F net will be plus QE and minus QE, which will give you zero value. So the two equal and opposite charge at the dipole forms a couple. Two equal and opposite, two equal and opposite, and what are those forces? That is plus QE and minus QE, form couple which exert torque. And what is the formula for torque? We have expression for torque is equal to either force, means you have to consider any one of the force because both of them are equal. So either force into perpendicular distance between two forces. So torque is represented by this symbol. So magnitude of one of either force is what? It is QE. And what is a perpendicular? As you can see here, it is a perpendicular distance. That is what? 2a sine theta. So torque is equal to QE into 2a sine theta. Now we are going to shift the terms such that we have another expression. That is Q into 2a into sine theta. So we see that Q into 2a is the expression for dipole moment. That is what? P. So we are going to substitute this value. Torque is equal to E into P into sine theta. So when we are going to write this expression in perpendicular form, we see that torque is equal to P cross E. So it is the vector form. And we know that torque is perpendicular. To the plane containing P and E. So the direction of torque, these are the important point which we need to consider in this one. The direction of torque is find through right-handed screw rule. And we are dealing with the condition, that is what? When torque is maximum. So torque is maximum when theta is 90, and that is how much? Sin 90 हो जाएगा, this value will be plus P. Similarly, for the minimum value of the torque minimum, we have to consider theta to be 0 or 180. In both the cases, we will get 0. So this is how we conclude the expression for the torque due to a dipole placed in a uniform electric field. And the expression is torque is equal to P cross E.